Hi, I'm Chris Mitchell with the Institute for Local Self-Reliance, where I'm the director of the Community Broadband Networks Initiative, which is fitting because today I'm going to be talking about an introduction to broadband technology, a little bit of the history, the exciting parts, and business models. This is all part of 4 presentations that the Southeast Nebraska Development District and the Nebraska Economic Developers Association have worked together to arrange in order to provide a good foundation for how we can improve internet access for everyone across Nebraska. And if some of you are sneaking in from elsewhere, you're welcome to learn from it too. I'll start off by just noting that I'm with the Institute for Local Self-Reliance, which is an organization that was founded in 1974. The Institute for Local Self-Reliance is a national research and advocacy organization that partners with allies across the country to build an American economy that is driven by local priorities and accountable to people on the planet. What that means when it comes to broadband is that we want to make sure everyone's connected to high-quality internet access. And we often do that with a specific focus on certain approaches. But today we're going to be talking generally across the board about what can be done. So I'd like to start by acknowledging that broadband can be intimidating and scary and something that you don't want to deal with. And it's something that we all are going to deal with, and we can have a little bit of fun with it. We can talk about this in ways that put it in historical context. And I'm not going to force anyone to memorize the difference between a bit and a byte because I don't think it's super relevant for you. Our goal when we're talking about broadband is not that everyone knows how many megabits are coming into your home, but that ultimately it works transparently for everyone, for large businesses, for small businesses, for ag producers, for residents. Just everyone is able to use it in a similar way that we use electricity today. I never had to turn off my lights in order to use my toaster. That's what we want to achieve with broadband. Our goal is not that we try to convince everyone that they need to learn the minutia, but that it works for everyone transparently. Now, I think it's important to talk about what broadband actually is today. There's a definition that the Federal Communications Commission uses, and that consideration is what does a typical household need to have in terms of speed and reliability and capacity in order to be able to take full advantage of modern applications on the internet. This is not what does one computer need or what does one person need. It's what does the sum total of the devices in a home, what do they need in order to be effective and not have problems from congestion and things like that. That's more or less what broadband is. Another piece of level setting that I wanted to do was to talk briefly about what the internet is, because I feel like everyone knows, but everyone also doesn't know what the internet is. And the way to think about it is the internet is the collection of a whole bunch of local networks, like thousands upon thousands upon thousands of networks around the country. You are on some kind of a network, probably if you're watching this video. Everyone's on some kind of local network. That might have been built by a cooperative, a telephone cooperative. It might have been built by a big corporation. You might be on a wireless network that's run often by a big corporation, but sometimes by a local company. There's any variety of networks. Those networks all exchange information with each other. So I'm recording this on my local network, and you'll be viewing it, and it will have traversed many other local networks along the way. The internet is the agreement of all these local networks to share. Now, what that means for you is your problem of getting on the internet is really one of having a local network that will work for you. And often the challenge of solving internet connectivity is twofold. One is, how do you build that local network that works for everyone in the area? And then how do you connect that with everyone else to make sure that you have a seamless example? Let's say that you're FaceTiming with a friend or a relative. You might be using that on a Wi-Fi network in your home. So as you're speaking, the information is going from your device over the Wi-Fi to a local router in your home. It's then traveling over the DSL network to fiber optic cables that are probably run by perhaps different companies to connect to someone else's network. They are getting that signal over fiber optic cables. It's going to a local tower, and that tower is then transmitting the information wirelessly to their device and back and forth, millions of times a second, effectively. That's the internet. It's a lot of different networks that all work together to get information to where it needs to go. So that leads to the question then of why don't you have a better local network available? And there's a person who says, his name's Richard Shockey, that I'll just name drop for a second because it seems to fit well. And he replies to everything by saying, the answer is money. What's the question? And so there's this question of then, how do we fund networks that will be great for you and your communities? And that's been a challenge. I like to say that we are kind of in the mid 1930s, I feel like, when it comes to where we are with internet access in relation to electrification. Electrification started in the late 1800s, and it picked up steam in the early 1900s. But it wasn't until the 1930s, when the electric cooperative model was both expanded and massively funded by the federal government, that it got to everyone. We're in that period right now where we often have a sense of the models we need, but we need to get the money out to get those networks built. That doesn't mean it's cooperatives everywhere, although in a lot of places it is cooperatives for the most rural folks. But that's sort of conceptually where we are. We know how to connect everyone. We know which technologies will work. And we can argue about which ones are better under different circumstances, but we are on a path to connect everyone with high quality access over time. We're going to talk over the course of these 4 sessions about different challenges and how we can do that. But for now, I just wanted to introduce the idea that it is important to know that this will get done. We are going to connect everyone, but it may take time. And frankly, some places will be connected sooner than others. And part of the reason you're here is because you want to get your community to the front of the list. As we're thinking about those connections, I think it's worth noting that some of these issues are a bit they can cause conflicts as we talk about different business models, some of which are public, some of which are cooperatives, which are in some ways a hybrid between public and private, depending on your point of view, and those that are private. Another parallel with electrification is that we needed investment from all 3 of these approaches, municipal, cooperative, and private sector, to connect everyone. I'm not arguing, and I don't think many would argue, that only one business model can solve all the needs. We use those models with electrification because there are very good reasons that private companies may not be able to connect people in rural areas or people in in urban areas that have very low incomes or other challenges to access. And so as we talk about different business models over this series, and as it may come up here, I don't think that we should think of this as one business model is great, and if only we used just that business model, we would solve all of the problems. We fundamentally need each of those business models in different places, I think, in order to make sure that everyone's needs are met. So with that, I want to go back to the 1990s, which was an amazing time in some ways for internet access, when the dial-up modems were still increasing in speed before we rejected those, to a time when we had a lot of choices of internet service providers in urban areas. And in rural areas, it wasn't always so good. Often there may have been a long-distance phone call involved or things like that. But it was still a magical time when the internet was growing and it was vibrant. And there was an argument over whether everyone would use email. I remember that argument well, this idea that you can't expect people to use email. But at that time, dial-up was the technology, and it used the public telephone system, something we often called the plain old telephone system, which was a system that allowed anyone who wanted to buy a bank of modems, to buy a bunch of devices that could receive phone calls, to set up their own internet service provider. And so we saw thousands of these companies. In fact, I think estimates are approaching 10,000 local companies were created to serve internet access to people as this got bigger and bigger, often on the order of $20 a month or $15 a month in the more aggressive price competition areas. And so for those of us that got online then, it was this remarkable time where you could get onto the internet and you had limitless access to information, it seemed like. And there was no major gatekeepers or anything like that. As our desire for more speed increased, in part because of things like larger photos and just wanting not to wait 10 seconds for pages to load, we had better technologies that were developed by people who should be very celebrated for it, in the DSL and the cable advances that turned, in the case of the telephone system, a system that was designed for just transmitting voice, to allowing computers to use an untapped part of that connection to transmit information. The cable networks went from a one-way distribution of video signal to being a two-way transmission potential, which was just remarkable to be able to take that technology and then deliver the fastest speeds that we could imagine at the time over that technology. Took remarkable breakthroughs that I think they should make movies about those people. But during this time, there was an interesting transition that I think some were aware of, which was that the small companies that created those small internet service providers that on the telephone network, they didn't always have access to the DSL networks in the same way. They didn't have the full access that they had in order to compete. And similarly, they didn't really have access to the cable networks hardly at all. There was some exceptions. So over time, they couldn't really compete in the same way that the companies that owned the wires could. And over the 2000s, we really saw most of those private companies go bust because they didn't have the ability to keep offering the faster connections that the bigger companies tended to because they owned the networks, particularly in the more metro areas. So cable and DSL kept getting faster and better, and they kind of leapfrogged each other a few times.
Everyone used to be friends in this neighborhood. But then everyone started sharing the same cable line for the internet. That's when things online got slower and...
Come on!
No, you're a weapon!
But throughout all this time, in the background, there's fiber optic connections, which have been used even back, even before the 70s. But it was very expensive as a technology, so people weren't running it all the way to connect homes. What happened was in about the 2000s, fiber optic cables became affordable enough and the gear became affordable enough that some entities like small municipalities, very aggressive private companies, and ultimately Verizon made a big jump to fiber optic cables in the mid-2000s.
Are you the cable guy?
Actually, I'm a Verizon Fios tech. I bring fiber optics right to your door on 3 different spectrums of light. You got your 1310, your 1490, and the 1550. The light is so clean, it's plus 20 dB hot.
Fios, which is still, I think, the largest fiber optic network in the United States in terms of the number of households served. So these technologies are developing simultaneously, but cable and DSL already reached everyone's homes, and the fiber optic cables had to be laid afresh. What that means is that it was much more expensive to build a fiber optic cable out. And over time, DSL just didn't have enough headroom to keep competing with cable. And so for the past 10 years, we've really seen cable winning because cable, even though it requires a significant investment to improve it to offer higher quality services, DSL just could not keep up. So some telephone companies embraced fiber optics, and the net effect is that there's actually less competition effectively over time for these high quality connections, to the point at which today, I think it's arguable that DSL barely even competes with a cable technology because DSL is just so slow. And there's real reasons for that. The copper tends to be a bit older. If it's been poorly maintained, it doesn't just transmit the signals as well. It really drops off over distance. So in a rural state like Nebraska, DSL is just really on its last legs. And in fact, as long ago as almost 10 years now, I think AT&T called DSL obsolete. Although they still do offer it in some places, they're really trying to shut it down in many places, and it's expected that other big companies will as well. So we have cable and fiber competing. The poles are where the DSL lines and the cable lines usually are, and it's hard to get fiber on the poles sometimes, so we use conduit, which is the pipes that we often put fiber optic cables in underground. This gets into a larger question of poles and pole attachments, and it's very complicated to get on the poles, is the terminology that we'll often use. So as we put fiber optics underground with new investments, we'll put them in conduit, and that leaves opportunities to put them in conduit banks, which you can imagine multiple hollow tubes underground that allow people to put fiber in. And then it's really expensive to tear the ground up and to place the conduit. But once that's done, you can put fiber through at a much lower cost, and you can keep using that over and over again. And so the costs of future investments are much lessened when there's conduit in the ground. Conduit is something that localities can get in the ground ahead of time as part of other projects. Something you may often heard called dig once, which is this idea of getting conduit in the ground when it's convenient, when it's low cost, so that if you later want to have fiber in there, or even if you want to have it right now, you can do it at a much lower cost. So as we're talking about the technology and the conduit, I think it's worth noting that as we go back to thinking about the DSL and the cable, this is how most people access the internet in recent years, more through the cable lines in particular, which have really taken over because it's the fastest service that's available. Cable and DSL, and even wireless to some extent, as well as fiber optic connections in some ways, are what we call asymmetric. And if we go back in time again to when DSL and cable were being developed, they had different technical reasons, but both of them had technical limitations that led to them making design decisions in which they prioritized the amount of information that could be sent from the internet to your computer, as opposed to information from your computer to the internet. At this time, it was well before there were podcasts. It was before YouTube. It was before even a lot of the streaming audio that became available in the early 2000s or late 1990s. But what that means is that we were stuck with this legacy in which people could download much more rapidly than they could upload. It wasn't as much of a big deal when we were mostly surfing around and reading things. There were a few people who were publishing. But over time, in part with social media, people do a lot more publishing. And now, particularly with the pandemic, we've really seen the importance of having robust upload connectivity. And in DSL and cable, we've often seen upload deprioritized because the expectation is people would be using more download than they are upload. As we're moving into this era of very fast networks, then we want to make sure that people are not limited on the upstream in the same way. And we're starting to see that with a lot of networks, both wireless and fiber optic, and soon cable as well. Cable's upload speeds are certainly far more robust than they were 10 years ago. But we still want to make sure that we have plenty of capacity in that upload direction. So that's something we call symmetry or asymmetry, which is basically what is the ratio of how fast, or not really how fast, but how much you can download simultaneously as how much you can upload simultaneously. And this is a particular issue depending on precision ag and small businesses who may need to be uploading a lot of information, especially for online backups for small businesses and things like that, banks especially. They really need to have that kind of connectivity. And over time, I think many more people will they'll want to have robust upload and download. As we're moving into talking more about wireless, I like to note that Wi-Fi is amazing. It is more amazing than anyone realizes. As you get into this world of deeper technology, we take it for granted that we can go out to the store and you can buy a product from one company, bring it home, and it will exchange information seamlessly with other companies, right? You don't have to buy a computer that works with your router. It's assumed that the router in your home that provides Wi-Fi will work with every device. And that is it's a triumph. It's remarkable. And on top of that, Wi-Fi operates in spectrum that has historically been what we consider to be not interesting. As the Federal Communications Commission divides up the electromagnetic spectrum that is used for TV, for radio, for all of the communications that happen wirelessly, there's a few areas that no one really wanted to deal with because it had potential interference or had other problems or was very crowded. And that was kind of the area that Wi-Fi was built in. And it used this area that was more or less disregarded. And it built this incredible value. I mean, I think you could argue trillions of dollars of value to the American economy, to the global economy, because of this technology. Most of us, when we're using mobile devices, we're using Wi-Fi. The LTE networks that are worth tens of billions of dollars for 4G mobile wireless, those carry a fraction of the traffic that Wi-Fi carries. And it's just a remarkable technology that, again, they should make a movie about it. That one would be harder than the engineers, but still, it's not impossible. Now, Wi-Fi is often used as a synonym by some people to just mean wireless, and it is its own thing. When we talk about mobile wireless, like what you may get from Verizon, AT&T, T-Mobile, and others, that goes to a mobile device, that's what we call mobile wireless, which is often using 3G, 4G, 5G, or LTE is often thrown in there as well. Those things are all in the mobile wireless world. And I think it's interesting to note they don't touch satellites. Some people assume that their cell phones go up to satellites. It's actually usually going a mile or so to a big, what we call macro antenna, which you'll see everywhere now if you just keep your eye out. They're often on high points in cities. They're all over the highways. And this is what has been powering our cell phones for a long time. Increasingly, we're seeing what we call densification, which is trying to take those macro cells and get the traffic to a smaller cell that is closer to a person. And so whether you're in your car or whether you're in your neighborhood, if you have 1,000 people all trying to share a macro cell, that gets to be a problem as people have higher expectations of bandwidth. So this is all in the mobile wireless world. We don't consider mobile wireless to be a competitor to fixed connections for a variety of reasons. One of them is this issue of overloading the macro cells if people are trying to use it too much. This is why even if you have an unlimited plan for your mobile data, sometimes you will get slowed down after you've used a certain amount because they don't want people to just be like constantly hitting against it and using up data that then makes other customers have a bad experience. So that, and then also it just tends to be more expensive in our experience than fixed wireless connections for comparable service. Some of these assumptions are changing with 5G because some of the carriers believe they'll be able to offer high quality access to the home over these small cells. And we'll see how far that gets and how reliable it is over time. But that's the mobile wireless world. Now, we also have fixed wireless, which is particularly relevant in places like Nebraska that are not West Virginia, where you have good line of sight. So fixed wireless is a technology in which both the antennas are fixed. So rather than mobile where you have a device in your hand, in fixed wireless, you might attach a device to your roof, or you might have a pole in your yard, and that will run into your home and create a Wi-Fi network for you. So rather than having a wire to your home that then you turn into Wi-Fi in your home, you would get a wireless signal to the side of your home or to a pole that would run into your home and provide that service. We call that fixed wireless because the two endpoints, the two antennas, are not moving around. This is a technology which is also improving dramatically in recent years. And there's a big debate, and we'll hear from people in this series that are both very bullish on fixed wireless, and as well as perhaps some people that are a little bit less enthusiastic about it. But what's important is that it is another option that is offering the opportunity to connect people across Nebraska. Fixed wireless can be anything from what we call two guys in a truck, which is two neighbors that may, or even one neighbor that was just frustrated with a lack of access, and they were technically inclined, and they put together a little network that may be connecting 100 neighbors or less or more. Over time, we've seen larger companies develop, sometimes by buying those local networks, sometimes by just being really aggressive and going out and building more towers and getting on towers and spreading around. So fixed wireless is something that comes in a variety of flavors and prices. And if you've had one experience with fixed wireless, that might not be indicative of the whole world of fixed wireless. Now, another kind of fixed wireless, we don't really think of it that way, is satellite service. And I don't want to get into this for too long, because if you know anyone that's used the historic satellite service, the geostationary orbits of these satellites that are 25,000 miles away from where you are, the service, it might have high throughput now, but it's still very frustrating to use because of what we call lag. You've ever been in a conversation where you're talking to someone and then they don't hear it for half a second, and then they talk back to you and you've already started another thought. That's satellite in the way we used to think of it. It's expensive, and it was great as a last resort for people who had nothing else, but it is also something that a lot of people are frustrated with and do not view as a good end state solution. But what we have now is something called LEO, low Earth orbit satellites from companies like SpaceX, which have a division called Starlink. Starlink is in beta testing, and I would say that thus far it has been delivering what it promised. It's better than DSL, not quite as good as cable in many of the tests. It expects to get a lot better soon. It is quite pricey right now, but and I don't think it's available in Nebraska quite yet, but it soon will be over the course of 2021. This is a solution that is very promising in many ways, but also has some challenges in that we don't know how it will perform if there are tons of people who are trying to use it. And it's not clear that everyone in rural areas will be able to be served by it, depending on density and other considerations. There's other companies that are also doing low Earth orbit satellites, so we may see other flavors of it, but we haven't seen much in the way of beta tests for those yet. Now, that was the technology. I hope it wasn't too painful. I'll try to keep it kind of light and relevant. But I want to talk about business models briefly, because as communities try to figure this out, sometimes that may involve community investment that would be working with a private provider. It might be investment in a private provider, but it might be, depending on how Nebraska law works in the future, there might be more options. We'll talk about this in the third presentation in this series. But the business models that communities should be aware of are the retail model, which is the one that you're most familiar with, which is where a network is owned by an entity, often a company, like, for instance, like Allo, a company that some of you may be familiar with. They often own the network, and they are the only service provider on it. If you're on the Allo network, you're getting services from Allo. Another approach is what we call wholesale or open access, where you might have a network that is owned by an entity. It's usually a public entity, which is not allowed in Nebraska currently. But there are some private companies that have done this, where the owner of the network will allow other ISPs to compete on it on the same terms. And that is something we call open access, when the goal is to encourage innovation and price competition out of a recognition that, whether you're in Nebraska, if you're in Western Nebraska or you're in Omaha, the simple fact is we're not expecting very robust competition because of the high cost of building networks. Whether that's a fixed wireless network or a cable network or a fiber optic network, there's just not a lot of promise for a whole lot of competition, because all of those things cost a lot of money to build. And that money is just offers better returns when it's invested elsewhere. It's worth noting that competition is important. Right now, there's no limit on what a company can charge for price. They can have really unreliable service, and we see that from some companies, unfortunately. None in Nebraska that I could name, but some of the other states that we work in have really frustrated their users, and it is against the law for a local government or a state to get in the way of any entity that wants to provide service, with the exception of subdivisions of states. Like Nebraska can say that cities are not allowed to get into this, but they can't stop a private company from offering service. What that means is that if there's not competition, there is a danger that the company who serves an area would abuse those customers. They might charge high prices, or they might have unreliable services. The solution to that is more investment. And that can be tricky in the current environment. So competition is important in part because the federal government and the states regulate in a much lighter touch than they would if they felt the marketplace was not capable of guarding against abuses of customers. Another model is a partnership, and a partnership can be just about anything. But common ones would be where a city builds something but does not want to offer services itself, or is prohibited by law from offering services itself, and so works with another entity. Lincoln is one of my favorite examples of this because I think it is tremendously innovative. Lincoln built a conduit network and then worked with private ISPs that would use that, because when Lincoln put the conduit underground, it lowered the cost of these companies to connect customers and to compete. So those companies then leased that conduit to get access to customers. They would often still have to do some of their own investment to connect the customers, but it was much less costly because some of what they had to do was more or less already done by the city. The city worked with multiple ISPs, internet service providers, to connect businesses and small businesses, medium businesses. But in other parts of town, they actually had an agreement with Allo, which is connecting everyone in Lincoln to a fiber optic network that uses that conduit system. And we would not necessarily expect a lot of different companies to come in to compete in the residential market, but you may see this more commonly in the small business market. So there can be some differences there, but that's a partnership approach. There's a lot of different partnership approaches where cities try to work with a provider to accomplish something that the city, again, might not be comfortable doing or may not be allowed to do under law. Now, as we're wrapping up, the last piece I wanted to sort of talk about before I get to what you should be doing, which is going to be quick. I want to talk about low-income challenges. And that's, I think, a common problem, which we think of more often in urban areas, but is very true in a lot of rural areas as well, is our networks are often aiming at a price point of $50, $70, $80 per month, sometimes more, depending on different assumptions. There's a lot of families across the United States who cannot afford $50, $70, $80 a month for service. We are seeing experimentation at the federal level and in some cases at the state level on how to deal with this. It's not realistic to think internet service providers alone, without the help of good public policy, can make their prices work for everyone. If your economics in rural Nebraska barely work, which may be the case for fixed wireless and for fiber optic technologies, it's very difficult to make business models work. And people often who are driven to try to provide a lot of benefits to the communities they want to serve, they're out there on the edge. And they can't just suddenly turn a bunch of their customers on at $10 a month without breaking their business model. So it's important to note that whether you're a big provider or a small provider, I do not think that what we might think of as charity from the private sector will be able to resolve this. And Nebraska may benefit from some federal programs. We'll see what happens in terms of how those develop. But this is a major consideration. I think it is the hardest problem to solve in broadband today. The rural problem, we need money, but we have plenty of models that work. In urban areas, trying to figure out how to connect low-income folks to networks that are already available but are not affordable, that's really hard. And in rural areas where the business models are on the edge, it's also very difficult to figure out how you can connect people at more like $10 a month for the folks that need that lower cost to be able to connect. And I mean, I suspect most of you would already be in agreement that this is a technology that we really need to make sure everyone benefits from. But just to spell it out, we do not want kids going home and being unable to take advantage of educational opportunities. We don't want parents cut off from economic opportunities. Making sure everyone's on the internet is rapidly achieving the same importance of electrification was back when we did it. At the time of electrification, when we decided that everyone needed it, I think internet access is around that point now. It's hard to imagine being a productive member of society without being able to have this opportunity. That leads us to the final point, which is what should you be doing? And we'll be covering that more in the next couple of sessions. But I think it's worth noting that there's a desperate need to get more people involved. So if there's something that you're trying to figure out what can you do tomorrow, I think the most important thing is to make sure that you are convening stakeholders, that those stakeholders are meeting on an occasional basis. I mean, we're talking about not just people doing economic development, but some people that have an IT background, perhaps from local government, some local businesses, residents, people that are affiliated with a library or schools, people affiliated with maybe higher education. The local leaders who should be thinking about this, they need to be getting together and thinking about it. And this is an important time to do that because the federal government is making more money available to local governments, to counties, to states, to school districts than we've ever seen before on this issue. And you're going to want to have input from all these folks in order to develop a plan and make sure it meets everyone's needs. Even if you're primarily an ag producer area or you're in Omaha, I think you want to make sure you're not leaving out some people. And the best way to do that is to convene wide, diverse groups that make sure that you haven't just forgotten someone through an innocent oversight. As you're bringing people together, I think it's worth noting that there are some organizations that you should take a look at. For instance, National Digital Inclusion Alliance. NDIA is a really wonderful organization that is focused on sharing the best practices of how we achieve digital literacy, digital equity over time. And they are a very easy organization to join, even at no cost. Although for organizations that can become members officially, that's certainly helpful. There's also something I always promote called the Michigan Moonshot. The Michigan Moonshot is a very interesting approach from what we call a research and education network in Michigan, which is to say all the schools and libraries, institutions of higher learning, they're often connected by this network. And Merit, that network, has created what they call the Michigan Moonshot, which is a ton of resources about how communities can understand more about this, get a sense of what their options are, and educate themselves, as well as create surveys and things like that in order to better educate the community and gauge interest in different approaches. As you are collecting these resources and having these discussions, I think key questions involve, what are our needs? What are our priorities? Is the focus to make sure that, like, for instance, all the people who can afford $50 a month have an option or multiple options? Is the focus on ag producers and making sure they have sufficient connectivity to make all the investments that they need to be very efficient? Is the focus on the low-income families, perhaps between 10 and 20%, in some cases up to 40% of folks who might not be able to afford options? Is the challenge more small businesses on Main Street? These are different problems. I think it's worth noting there's not one broadband problem in Nebraska. There's a series of problems that have a common element of broadband, and one approach that solves one of them may not even touch another one. So as you're considering this, you have to think concretely about what are the specific things you're trying to solve, and what are the priorities then among those. Because I've certainly had people tell me, oh, all of those things, we want to solve all those things. And that's wonderful, but that's going to cost a lot of money, perhaps more than you're willing, and so you may have to prioritize. Ultimately, we do want to make sure that all those different problems are resolved, but different communities have different assets and different challenges that may make sense to tackle them in different orders. So that's the first thing is we need to get people organized. And then you need to think about, I think, whether or not you have the local networks that meet your needs, which, is primarily a question of like technology and economics and that sort of a thing. How you would interconnect that to the wider internet, which will be a challenge in some areas and trivial in some others. And then making sure that everyone is able to use it, which we often call digital inclusion, which is not just cost, but also literacy, making sure people feel comfortable they can use the internet safely, and making sure that people have a device or multiple devices for the household that will allow them to do what they need to do. So that's more or less Broadband 101, and I hope it's been interesting. I feel like we should have an alarm clock noise now to make sure people wake up and they're not drooling into the keyboard. But I am very open to feedback on this, and we'll be doing future sessions. So if you want to contact us and the folks that made this possible, and I hope that this is something that will help you as we make these really important investments to make sure that everyone benefits from this amazing technology. Thank you very much.